Hello everybody, this is Jason. If you are a returning subscriber, welcome back. If you are new here, welcome. I post content related with WebRTC, JavaScript and Golang. If this interests you, please hit that subscribe button and stay updated. Welcome back everyone. It's been a while since I uploaded any new videos. Apologize for that due to some busy work and everything. But now I have decided sort of dedicate some time, at least one video a week. Probably will happen more likely to be weekends, but keep an eye on my channel. If you haven't subscribed, please subscribe. Okay, what I got you guys today is getting started with Rust Mediasoup, like writing the back end of Mediasoup with Rust. Okay, of course this is going to be like a really entry level tutorial. We're going to do an eco test. Okay, so I'm going to show you what we're going to build before we get started. Okay, so what we're going to do is I'm just going to show you what we're about to build. Okay, basically we're just doing an eco test. Okay, but the logic is actually the same if you do like a many-to-many conference, but this will give you some basic understanding of what's going on with the how the infrastructure works and stuff. Okay, all right, enough talk. Let's make it start on this. Okay, to start off, we'll make a new project. We'll cargo new, and we'll call this eco test. Okay, and then we cd into the directory, clear that, and then open our IDE. Okay, first of all, we will need to add some dependencies. Okay, so let's add some dependencies. Okay, the first one obviously is Mediasoup, and the latest version we're going to use is 0.11.4. okay, and the second one is Tokyo. Okay, we're going to use straight Tokyo. We're not going to use Actix. I know there is a example on the Mediasoup official site, but they are using Actix for that. So I'm going to show you something different, because what we're about to do is more closely to the like the native way, not rather than having to learn like how Actix work and stuff, and also like it's more lightweight this way as well, and also it's a lot easier to understand. Okay, and the version of Tokyo is 1.32.0. okay, that's the latest. And then we're going to add the features. We will just use full. Okay, alright, and the next thing we need is WAP. Okay, WAP is the framework we're going to use, okay, for our WebSocket server. Okay, looks like we got a typo here. Alright. Okay, that's good. WAP, and also we will need UUID. Okay, we need this to manage the room, okay, or user. And the version we want is 1.4.1. and the features we will want v4. okay, we want version 4 of the UUID. Okay, and charade, however you pronounce that. Okay, and the version we're interested in is is version 1.0.184. okay, and the features we want is derive. Okay, this is for JSON serialize and deserialize. Okay, and we're also going to grab this as well. Let's go that. Yep. And the version we want is 1.0.105. okay, you can just put 1 if you want, but it's all good. Okay, and that will do for now. Okay, we might need some more, but we will come back later. Okay, now we will go to our main RS and start making our server. Okay, for the aim of this session, we're going to try to get the WebSocket server up and running. And then we will get into the Mediasoup stuff after that, okay, because this will take a bit. It's not our main focus, so we're just going to zip through this, okay. So up here we need a header, okay, and it's Tokyo we want, and the function we have to change that to async. Okay, and let's make a start on this. Okay, first we need to define the address, our socket address. Okay. Okay, let's address attr, and we grab that from our environment file. Okay, we don't have one yet, but I will show you a way. If we don't have one, we can actually set a default value. Okay, so we go unwrap or else. Okay, so if we don't have an environment file, or we haven't set it, then we're going to use this address, which that's what we're doing. Okay, and we want that to be in port 4000. Okay, and we change that to a string. Okay, and then now we're going to do the socket address. Okay, socket address. Okay, we'll type this. Okay, and we grab that from the attr. Oops. And we're gonna pass that and expect. Okay, and we'll put a message in there, say invalid socket address. This will never happen because we just put a default value, so this will never be, you know, we will never hit that, but it's a good practice to do that though. Okay, let's save that. What? Expecting a semicolon. Huh. Okay, let's see, close these files. Okay, next thing, we have to prepare our server here. Okay, and we're going to start off signaling. I just call it signal, okay, because you can call this whatever you want. This is like building up the actual WebSocket server. Okay, and WAP path. Okay, so this is the path where we hit the server. You know, when you go WS or WSS column and then localhost, and you have a slash, that's the path. Okay, well, that's what we're building up right now. Okay, and this will be the WebSocket server. We pull that in here. It's a WebSocket server. Okay, and then we're going to map it and a closure. Okay, we're going to get a WebSocket server. Okay, we import that. And then we're going to build a separate function for this. Okay. and we're gonna go WS on upgrade. Okay, this function will get triggered, okay, as soon as someone hits here, and we're gonna move it, call this socket, and then we're gonna pass it on to a different function, okay, so we don't do everything in one file. Okay, it's a good practice, because when you do production apps, okay, you never put everything in one file, because that will be really hard to manage like later on down the track. Okay, just save that. It's good practice to save all the time. Yeah, spell async wrong. Not sure why my code format is not working, but anyway, that's not important. Alright, the next thing we need to do is the routes. Okay, we're going to do, actually we're going to do a 404 page for this as well, okay? Because when, when you hit the server with the wrong address, we want to return it as a 404 not found. Okay, what we're going to do here is we're going to do a page for that. We will do a simple HTML file later on, okay? We haven't done that yet, but we will, okay? So the 404 will be a wrap any map. Okay, it's a closure again. Okay, now we're going to construct the what do you call it, the return of the like when someone hits this, we want to give a status code and also redirect the user to a 404 page we're going to make in a sec. Okay, so now first of all we need to construct the response. All of this stuff is on the documentation, so if you're not unsure, okay, go and check out the WAP documentation. As I said before, this is in our focus, so I'm not going to go too deep on how to use this, but if you're interested, you know, like coding in Rust, leave me a note and maybe I can do some, you know, like core videos, you know, just based around Rust. Okay, actually I'm probably going to do that, but not right now. Okay, we'll finish this thing first. Okay, now we're going to the body of this return. We are going to read from, hold on, fs, we want to import that. See, if we don't import it, we don't get the code completion. Now we will. Okay, we want to read it from file, and we're going to give it a path. Okay, we'll say HTML. Okay, this thing doesn't assist yet. Okay, we have to make this in a sec. 404 HTML. Okay, that's the file. And here's some like error handling. Okay, expect we cannot find the 404 HTML page. Okay, that's just for us to see if that ever hits. Okay, we don't need that. Okay, so that's our 404 page done. Okay, now time to deal with the routes. Okay, so what we're going to do here, the route is to clarify. Okay, if we hit, for example, if we hit our WebSocket server /ws, if it doesn't assist, then we want to present the 404, and that's what this route thing we're about to do is going to do. Okay, so let's do that. Routes equals wrap. Oh, sorry, we need to bring in the signal. Okay, we need to see if the signal gonna go through. If not, we go OR, and then we will present the user with the res 404. Okay, all of this stuff is in the wrap documentation. Okay, it's nothing fancy, it's pretty basic stuff. Okay, and now we construct our server. Let's call it WS server. Okay, equals serve. Okay, and well, that is a function, and we're going to put in our routes in there. The completion is not working. Okay, the macro we want to use is try bind. Okay, that will appear once we implemented this function here. Okay, right now we just put it in. Okay, but we'll come back later to make sure, you know, this is there. Okay, if it doesn't, then obviously it's not going to work. Then we're going to put the socket server we made above here. Okay, let me close that tree so get a better view here. Okay, and then that is it with this function. And now we want to print out so it shows you every time you start up your server which address this WebSocket server is hosting on. So let's say running server on, and we'll just put in that address. And last thing here, ws server dot await. Okay, because it is an async function, so this will hold up everything, you know, until this thing's done. Okay, looks like that's not imported. There you go, that's what we want. Okay, now it's imported. Okay, look, the only error is here, which we are going to make that now. Okay, and let's go into here, create a new folder. Let's call it server, and make a module file in there. Okay, and also we need to make our actual server file. Okay, server.rs. Okay, and in the module folder we need to put that in there too. So this has to be a public module, and the file we want to include a server. Okay, because the completion is not working because we haven't actually imported in the main rs, which we need to do that here as well. So we go mod server. Okay, okay, now we're good. Okay, now let's make this missing function. Okay, and it needs to be a public function, and we called it start ws, didn't we? Okay, before we go any further, let's correct this. Okay, that should be a function. Okay, let's do this first. We need to import a couple more crates for this to work. Okay, we need to use the type of WebSockets, as that's what we're passing in. So we save. Okay, and now we go back to here. We need 2 more crates. Okay, the first crate we're going to need is features. Okay, we need that to split that stream. Okay, we need to split the WebSocket stream so we can use it like sending and receiving in a different thing, so we don't have any ownership issues. Okay, to be honest with you, in Rust, I think the most difficulty thing is the ownership. Okay, good to learn that stuff, you know, because that normally takes most of the time, you know, to sort out. Okay, and the version we want is 0.1. What is it? 1.4, I think. Oh, 1.4. Yep. Okay, save that, reload that. Okay, and one more crate is called features. Okay, and the version we want is 0.3.28, I believe. Yep. Save that and reload. Okay, and now we can get out of this file now. Okay, we'll go back to our server file. Let's close that. Close the mod, and let's close the tree as well so we can get a better view here. Okay, let's start making this function. Okay, first thing, we will need to split the stream, as I said. Okay, so what we're going to do here is we go let, put that in a tuple. Okay, and then we want the user, let's call it user sender. Okay, and the receiver need to be mutable. Okay, receive, spell receiver. Okay, that equals WS, the WebSocket getting passed in, and we need to split this. See, the split function is there. All right, the next thing we need is we need to make a channel. So we, what do you call it? So we can pass this in the spawn, which is in multi-thread. Okay, because if you try to pass this stuff around, it's not going to work because these are ownership. Okay, and you cannot clone these. Okay, so what we're going to do is we will make a Tokyo channel. Then we can clone and pass it around to the multi-threaded. Okay, so it's common that you need to do that. Okay, it's a tuple again, and that's a RX. It's basically TX. Oh, TX is the sender, and this is the receiver. Okay, that's what that is. And then we're going to use the unbound channel. Okay, so we can like use in multi-thread that we can send back. Unbound channel. Let's make sure that is the Tokyo library we're using for the unbound channel. Yep, it is. And close that off. And we need to do another thing. We need to use this future stream receiver stream. Okay, so then we can use the RX to forward it to in a thread, so you can like consistently reading the stream. Okay, so what we're going to do here is we go let, okay, RX. Okay, we're going to do the RX again, and the RX will have to be equals to unbound receive stream. Okay, which is, oops, receive a stream. Okay, and that will automatically import from Tokyo stream. That's why we needed that. Okay, if you're wondering. And we go new, and we put the RX in there. Okay, and now let's do a save. Just a good habit, you know, to save anyway. So okay, ignore this now because it expects a type for this. Once we write the rest of the code, this error will go away. Okay, so just ignore that. All right, the last part we're going to do in this lesson is we're going to read all the incoming messages. Okay, for the WebSocket. Okay, we're just going to do a while loop. Okay, let some results. Okay, and that will come from user receiver dot next dot await. Okay, and then we're going to do a match. Okay, let messages message. Okay, and we're going to match the result that comes in. Okay, we need to match results. Okay, if it's okay, we will return a message, MSG. If it's an error, we will just simply print out the error and break the while loop. Okay, so print line error, we see message, and we're going to print out our error so we know what it is. Okay, it's E. Okay, and then we're going to break this loop. Okay, so what we're going to do here, basically we need to pass the messages into another function. Okay, the reason why I'm showing you guys all this, because this is way more complicated than writing everything in one file, because when you write everything in one file, that means you don't get the best practice of actually writing any Rust production applications. When you do that, like the way I'm showing you now, you will run into a lot of, you know, like ownership issues. It is a good practice to write your code like this rather than slap everything in one file, and you know, there's no difficulty about that if you know that's what we're going to do. Okay, so what we're going to do here is we're going to like create another function that will handle this messages. So we call this message handler. Okay, we haven't written this function yet, okay, but we will, and ideally we're going to pass in the message to that, and then we will handle the message in that particular file, you know, to do the Mediasoup stuff. So therefore I'm going to stop this lesson like right here and then we will get into the Mediasoup stuff on the next one. Okay, and I hope you enjoy it, and yeah, I didn't want to drag, you know, a lesson too long, otherwise you get bored and stuff. Okay, we'll see you in the next one, and thanks for your time watching.